All right, here we go. Number one, I give you a graph and I ask you to write the equation. So 14, 7 goes by twos, 2, 4, 6, 8, 10, 12. This thing starts in the middle, the bottom, to the middle, to the top, to the middle, to the bottom, middle. So things that you should notice when you first look at this and start to think, okay, I've got to write a function, is make the decision if you're going to go with sine or cosine. For me, when I look at it, if it starts in the middle, I'm going to go with sine. Okay. This thing does start in the middle. It actually goes down first. Your standard sine function actually starts in the middle and goes up. But that's okay. So we can get this shape if we just reflect this graph here over the x-axis, which all you got to do to do that is put a negative out front if you're going to reflect over the x-axis. So we can take care of that. So I made the decision. I said, hey, this thing is going to be a sine function. Okay? This is going to be a sine function. I'm actually going to put a -1 right here for now because I do want to reflect it over the x-axis to get that shape. Once I've made the decision that it's going to be a sine function, I start to think, well, am I going to have to shift it? No, I don't, because it starts in the exact middle. It starts right in the middle. So you're not going to need to shift this thing left or right to get the shape correct. So that's really nice, is you don't have to horizontally shift this thing. Next, as far as horizontal goes, is the period. So when you look at this graph, starts here, goes up, goes down. Now it's right back to where it started. This would start really the next iteration of the pattern. Okay. So the period on this thing is 8. So that's going to play a part in my function. Period is 8. Okay. Whatever you put next to theta, 2 pi divided by that needs to be 8. So you can just come up with an equation, right? 2 pi over some unknown, call it x, needs to equal 8. Solve for x. Multiply both sides by x to get rid of the fractions. 2 pi equals 8x. Divide both sides by 8. X equals 2 pi over 8, which is pi over 4. So pi over 4 is what goes right here. Now, other thing I notice is normally the amplitude of sine is 1. Okay? From the middle to the top, from the middle line to the top, that distance is 1. Well, what's the distance from the middle line to the top on our graph? 7. So that's going to take a vertical stretch by 7 to stretch this wave out. So vertical stretch, where does that go? Yeah, good. So we'll put it right here. I'm actually going to combine these two guys. So below I'm going to write it as -7 sine pi over 4 theta. And the last thing is the middle. Okay. If you left your function, if you looked at a graph of this function right here, it would actually look like this guy right here. So what do you do to take this guy right here and up 7? So if you just tack that +7 onto the end, you'll have it. So our final answer was negative 7 sine pi over 4 theta plus 7. Yeah, there's actually infinitely many solutions to this, if that makes you more comfortable. Because the thing is, like, you could actually take, if you take the graph, let's say in black, okay, the one you started with, how far would you have to slide it left? How far would you have to slide it left so that you came up with the same exact pattern? Anybody know? Yeah, 8. So if you shifted this thing left 8, which is the period length, or right 8, or left 16, or right 16, or left 24, or right 24, you're going to end up with the same graph. Also, you could have done this thing with cosine. You would have had to shift cosine so it didn't start at the top, but you could have done it with that as well. So, if you're really wondering, does this model work, and you have access to a graphing calculator, graph it. Graph it. Okay, any questions on number 1 before we proceed? Okay, big takeaways for me were, look at the period. When you look at this, you have to identify that the period is 8. So 2 pi over what equals 8? That'll give you what goes next to theta. Then also make sure you identify, is it going to be done with sine or cosine? I know, Sarah, it could be done with either one, but one of them is going to be more efficient. So pick the one that's going to be most efficient. Okay. After that, check out the amplitude. That's from the middle to the top. The standard sine function or cosine function has an amplitude of 1. What does this function has? Well, it's 7, so that's that multiplied by 7. And I did that vertical shift last. So, okay, number 2. Number 2, you got to graph this function. Theta minus pi minus 6. So how many transformations? 3. Okay. How many horizontal transformations? 1. Let's do that one first. What is it? Right pi. Good job. Right pi. Then the verticals are next. You want to do the, as the function sits, what happened first? The stretch by 2 or the down 6? 2. Okay. Good job. V stretch by 2, and then we went down 6. I'm going to do the vertical stuff first. It doesn't matter. But when I set up my scale on here, I'm going to use that vertical stuff to help identify the top, middle, and bottom. So this is a sine curve. Normally the top is at 1, the middle is at 0, the bottom is at negative 1. So let's just say we did the vertical stretch. So the top goes from being at 1 to being at 2. Okay. The middle, which used to be at 0, is now at... Oh, you were doing one at a time. We're just doing the vertical stretch. It's still at 0. Good job. Because you multiplied it by 2, and it's still 0. And the bottom is where? Negative 2. So the vertical stretch piece is done. Now the down 6. 2 is going to become negative 4. 0 is going to become, and negative 2 is going to become negative 8. So that sets up those lines for you. Negative 4, negative 6, negative 8. So the vertical stuff is all done. It's just a sine function. We've just got to take care of the last thing, which is right pi. This is right pi. So, wouldn't you guys, and Kind of seems like you're visualizing it in your head and just moving it around, which is great. You're probably right. I can't look that many steps ahead. So what I do at this point, because I can't visualize it that far, is I would lightly sketch the sine function. I'll just do it in like purple here. So I'd say, well, if it's the normal sine function, period is 2 pi, pi over 2, 3 pi over 2. If this thing did not have the shift right pi, it would look like that. And I'm actually gonna, this guy here is at negative pi over 2. Back here would be at negative pi. You can keep the pattern going in that direction. So one strategy is sketch it without the shift and then just take that graph and move it. So every point needs to go to the what? Right pi. Okay, so there's a reason I chose this point, because when I move that guy to the right pi, now it goes to 0. Yeah, I think that's what you said, Dayton, earlier. So we got this point. So that one's taken care of right there. What about this negative pi over 2 point? Where does it go? Pi over 2, yep, goes to pi over 2. What about this point? Goes where? Okay. What about this point? See if you and your neighbor can agree on where this one right here goes. Okay. So now you've got enough of the pattern here. So there's one period of it, and you could certainly continue the pattern. But that's it right there. So what questions do you have? Three. Oh, maybe are you looking at this guy here? Sorry, you just couldn't read my writing. Yeah, definitely 3 pi over 2 there. Somebody last class asked also about, like, what if I just relabeled the x-axis and I move the y-axis? That's fine. Like, you're thinking through it the correct way. I think those are the worst problems. But, as far as how the process went, I identified the transformations. Me personally, I do all the vertical stuff first. I set up my top, middle, and bottom line. Right. This thing, we didn't have to adjust the period because the number in front of theta was 1, so it's just 2 pi. And then I sketched it without the horizontal shift, and then I was able to see the picture and move everything over. Okay, we ready for 3? 3 isn't bad. So, hey, as I get started drawing this for 3, I want you to be thinking, is that sine or cosine? Brandon, what'd you decide, sine or cosine? Okay, why'd you say sine? Oh, okay. Yeah, you're right. That's how I look at it. I think it's most efficiently done with cosine. If you think about having a top, if you think about having a top, a middle, and a bottom line, this thing starts at the top. If it starts at the top or the bottom, I'm going to go with cosine, because then I don't have to bother with any horizontal shift. All right, first question. Determine the amplitude and the period. Okay, what's the period? 365. And if you're wondering, you start tracing the curve. Stop when it starts to repeat itself. Right there. Well, go to the x. That's 365. Okay, the amplitude. Guys, the amplitude is half the distance from the top to the bottom, or it's just the distance from the middle to the top. 35. Amplitude is 35. What? No. I don't believe you. Amplitude here is 35. Okay. So, now that we've got those set, we can start to write this function. Let's take care of the whole period thing. So 2 pi over what equals 365? So if you solve for x, multiply both sides by x, you get 2 pi over 365. It doesn't reduce nicely. 182.5. You guys said cosine, so I'm going with cosine of... That's fine if you want to write this as pi over 182.5. That's fine. Is there any horizontal shift? No. So that's super convenient. What did we say the amplitude was? 35. Where's the middle of this graph at? 60. So where's the middle normally at? 0. So you had to shift the middle up how far? 60. Cool. All right, take a quick break.